Space. Wanna go to space. Gotta go to...
The two focuses of the structure team are to provide the physical CubeSat skeleton structure
and to create mechanisms to deploy both the extendable mirror arm and the CubeSat's antenna.
The skeleton structure, much like the human skeleton, provides support and protection for all the internals, or guts, of the CubeSat. For this reason, the structure must be strong enough to withstand the immense vibrations of a launch, while also staying below the maximum weight and dimensional requirements of the CubeSat specification.
Up to this point, the structural team has designed a CAD model of the entire CubeSat. First, we created a very rough cardboard model to get an idea of the internal layout. This model was used to create a general CAD model of the outside structure, which was then used to create a 3D plastic model. Using this 3D plastic model, we were able to experiment with different assembly methods. Currently, we are putting the finishing touches on a refined CAD model.
In designing the antenna model, we began by creating an idealized CAD model of the antenna components. Using this model and the advanced simulation software available with NX 7.5, we were able to simulate the motion profile of our antenna on deployment. Take a look. Wow, that was intense! We're now in the process of building a prototype of this deployable so that we can verify this simulation through real-world testing.
So at this point in time, we have a nearly completed structural design. However, we will need to concentrate further development in a few areas. One area is the development of the thermal knife, which is the mechanism used to deploy the antenna and extendable arm. Here, we have our deployable being held down by a monofilament, which is similar to a fishing line. We use a nichrome wire, similar to the wire in your toaster, with the current running through it to heat and sever the monofilament, thus releasing the deployable.
Another area in need of further development is the method used to stabilize and orient the CubeSat. The initial design relied on the extendable mirror arm to induce a gravity gradient and align the satellite with the Earth's gravitational field. We currently are assessing the feasibility of the system and considering other means of self-orientation. One potential alternative is the use of a magnetorquer, which uses electromagnetic coils to align the CubeSat with the Earth's magnetic field.
All in all, we plan to have a completed design and prototype, including all CubeSat components, by the end of May. Up to this point, we have only made partial prototypes, leaving out some parts of the design. This first complete prototype will serve to provide insight into any problems with our design that were not apparent in the CAD model.
Once this entire model is completed, the remainder of the summer will be spent performing thermal and vibration FEAs, or finite element analysis, on the different components of the model and addressing any issues that arise. The team plans to have this analysis and final model completed by the 1st of October. Final simulations of testing will be performed on this entire completed model to reaffirm the validity of the design.
Once the computer-aided simulations have been completed, technical drawings of all components will be created in order to begin manufacturing these components. The target date for the completion of a machine prototype for testing is December 1st, 2013. The completion of this prototype will allow validation testing to begin at the start of 2014.
In all the design work that has been done this semester, we've learned two major lessons along the way. The first lesson learned in designing the structure was to maintain regular communication with all other subsystems in order to fully understand their needs. Since the structure is the glue that holds the entire CubeSat together, the structural design must be able to accommodate all other subsystems components. The second lesson we've learned is that the devil is, in fact, in the details. Many of our redesigns have been a result of missing small but crucial requirements in the design.